Hello, all Algebra students. This is Mr. Fleming coming to you from my parents' living room. And I wanted to do another recording of the class we did on Monday, just in case you missed it, so you can watch this video anytime. So I'm going to go ahead and start the presentation. There's a quick little thought activity, and then we'll go into reviewing for the final. The final is going to be on Google Forms, and we'll go over that on the presentation. Okay, so without further ado, I'm going to share my screen, and we're going to do the presentation. Okay, so the first thing I want to say is Black Lives Matter. There's been a lot of stuff going on in the news, the protests, and I wanted to do something in solidarity with the people protesting against police brutality against Black people. And in order to challenge racial injustice, we have to look at data often, and that helps us understand some things. So this is an infographic I found from Mona Chalabi. She is an artist and an activist, and she used information from an organization called Mapping Police Violence, which tracks, the police brutality against Black people in the United States. So she found, or the data that was found was of the 7,666 times that police officers kill people in the US between 2013 and 2019, only 25 resulted in a conviction, which is 0.3%. It's less than 1%. 74 or 1% resulted in a charge with no conviction. And this is a bar graph, so you can see. And here's the other bar graph, the other category. It is quite long, very long. Yeah. So the vast majority of cases, or 98.7%, resulted in no charges whatsoever. I think this is inexcusable, and the system of policing in the United States must change so that no more Black lives are lost to police brutality. Okay. So also I wanted to say something along the lines of, it's been super hard with the school closure period to work on some math, but I'm so proud of everybody for working on your math skills during this COVID-19 period. It's definitely not the same as before, but I enjoy talking to you guys in small groups or one-on-one, and holding the Zoom classes. It's a really nice way to connect. And I also want to, say that by studying Algebra 1, you're laying the foundation for success in your future math classes, such as geometry, algebra 2, pre-calculus, calculus. It all builds up. So the work that you put in right now will pay off with success in math classes in the future. And also, math can be an important tool for justice. Oftentimes, with numbers and data, humans are the ones that are collecting measurements and collecting these data and making graphs. So there are ways that people use data and numbers to hide the truth. With math, with an understanding of math, you can protect you and your community from getting ripped off by a company, perhaps a majority white company, with unfair pricing. With math, you can see through graphs that can be used to mislead us. So a kind of invented example, this isn't, a real graph, but this is just an example to show how people can, change your opinion with just a graph. So if I look at this graph without looking very hard, because, I'm tired, I see that, wow, Democrats agreed with the court and Republicans and independents didn't really agree with the court. But then someone did a graph using the exact same data over here, and we can see that, well, this graph on the right looks really different. You can find that, well, actually a lot of Republicans and independents supported the court, maybe 54%, where that first graph on the left it didn't look like it wasn't that, because the scales are different, right? And that's important. So, with every graph or table or data you look at, infographic, just like in English class, you have to think, who are the people making this graph, and what is the author's intention? Who is this for? So hopefully, as you work on that delta math, I hope this inspires you to keep going a little bit. Okay, so we're just going to quickly run through some announcements. So those slides weren't quite great, but the homework this week is in this case, it's not a survey, but it is a 5-question Google Forms quiz. And it's a practice for the final, which is going to be pretty soon. So the more you're familiar with Google Forms, the better. So please do that. You'll get some extra credit if you do. And catch-up time, there's no new assignments besides that extra credit Google Forms practice, but you should be working on delta math if you haven't, got those review assignments done, work on the word problems assignment, and then work on your how-to project. These things are going to help you study for the final, so you might as well. Okay, so all quarter 4 work is due on June 17th, and then the math final will be on Google Forms on June 19th. Please make sure that you sign up for your time. I think there's 3 times, one in the morning, one in the afternoon, and one in the evening. So please sign that up. Please do this by, at least the end of the week, or I'm going to assign you a time, and you can email me to change it later. But do it, please. Okay, so that would be it. Yep. So I'm gonna move on to the whiteboard now, and we're gonna start reviewing some of the stuff at the final. So I'm gonna go share my whiteboard now. Okay, so the things that we're going to review today are going to be fractions. You're also going to be doing like advanced combined like terms using exponents. And then we're also going to be learning, just reviewing exponent rules. The last 2 topics are topics that we didn't cover directly in algebra class. We covered them in the packet that was sent home back in March, so that's why I just wanted to reiterate them now. There'll be a couple questions on the final about this, and I think you can do it. All right, so I know you might be saying like, oh my God, why are we starting with fractions again? But honestly, this stuff is kind of tricky. It appears a lot in geometry, algebra 2, even calculus, and also on the MCAS. So the more that we understand fractions, the better shape we're going to be in. So I'm going to start drawing a little bit. So some lingo you have to know. This is a fraction. Remember that that line in the middle is a division sign, basically. This is just a representation of 2 divided by 5. Or sometimes we say 2 over 5 or 2/5. Remember that the top number, we refer to that as the numerator. And then we refer to the bottom number as the denominator. So please remember that because we're going to be using these terms throughout our review of fractions. So oftentimes when you have fractions, they can be simplified. Because say you have a fraction like this, 5/20 or 5 over 20. So we need to write this in a simplified term. So I noticed that both 5 and 20, they go into 5, right? So I can divide the top and the bottom by 5. And that's how to simplify it. Divide up on the numerator and the denominator by the same number. And I know that 5 divided by 5 is 1, and 20 divided by 5 is 4. So that's how we simplify this. Because 5/20, it's not really useful to say that. It's way better to say 1/4 because these 2 are the same thing. Okay, so we're going to be reviewing, multiplication of fractions, division of fractions, and then adding and then subtracting a fraction. So we're going to go through all the 4 operations because you have to be careful with each one. So multiplying fractions is probably the most straightforward. So say if you had 2/5 times 3/4. What you need to do is simply multiply the 2 numerators and then multiply the 2 denominators. So I'll just do this in a step here, 2 times 3, and then 5 times 4. And then that's 2 times 3 is 6, and then 5 times 4 is 20. And just like before, I realized that I can simplify this. I know that 6 and 20 both go into 2, so I'll divide 6 by 2, I'll divide 20 by 2, and I'm left with 3 over 10. I can't simplify that anymore because I can't, divide something by 3, divide something by 10, and get a whole number. So that's good. So the next thing we're going to do is divide. So say we had 2/5 divided by 3/4. So in other math classes, perhaps in middle school, you might have heard the famous phrase, keep, change, flip. Okay, so what this means in mathematically is to divide a fraction, you keep the first fraction, you change the second you change the division sign to multiplication, and then you flip the second fraction. Oftentimes we call a flipped fraction a reciprocal. So a reciprocal just means flipped fraction. Okay, so I'm going to do 2/5, keep, change it to multiplication, represented by this dot, and I'm going to use the reciprocal of the second fraction. I'm going to flip it. So times 4/3. Perfect. So then I'll just multiply fractions like I did up here. 2 times 4/5 times 3. So 2 times 4 is 8. 5 times 3 is 15. So that is the answer. We can't simplify that anymore because there's no number that goes into both of these numbers. Okay, adding fractions. This is where it gets a little bit more tricky. So say we wanted to add 2/5 and we wanted to add it to 3/4 this time. So what we need to do in order to add fractions, we need to make the denominators the same. And the way we do that is using something called least common denominator. So you have to find a number that is in common between the two numbers in the denominator and then multiply the top and the bottom of the fraction to get to the same. So 5 and 4 don't really have a lot of numbers in common, but so the lowest thing that they share in common is them times each other, which is 20. So if I make the denominator 20, I can make them the same. So I'll multiply 2/5 by 4/4. So that way the denominator is 20. And then I'll multiply 3/4 by 5/5. Which will make the denominator 20. I can do this in math because 4 divided by 4 is just 1. So you can always multiply something by 1 because it's going to be the exact same thing. So if we do that, we'll do like 4 times 2 is 8, and then 5 times 4 is 20, which is great. And then 3 times 5 is 15. And then 4 times 5 is 20. So great. So now that we have changed the fractions at the same denominator, we're going to keep the denominator the same and then add the numerators. So this is going to be 8 plus 15 over 20. Okay, so then 8 plus 15 is 23. And then I'll keep it over 20. I'm going to leave it as the improper fraction, which just means the numerator is bigger than the denominator. It's usually better in advanced math classes as you go through high school. Okay, the last thing we're going to do is subtraction. So say we have 2/5 minus 3/4. Okay, so again, to do this, we need to change these two fractions to have the same denominator, but luckily we did that already. So 2/5 is the same as 8/20, and then 3/4 is the same as 15 minus 20. So then don't forget your negatives. So this is going to be 8 minus 15 over 20, which is going to be 8 minus 15 is -7 over 20, and I can't simplify that anymore. So that is a review of operations with fractions. These are tricky. Practice with them. They might have been reviewed, but hopefully this was a little helpful in having it all in the same place. So if you would like to take notes, please take a screenshot of this, or you can pause the video and then come back when you're ready to go. Okay, so I'm going to go clear this, and we're going to move on to the next topic. Okay, so the next topic I have is advanced combined like terms. So, we might have learned about combined like terms in the past, in middle school, but this is just making sure we know how to do it with exponents. So say you have 7 plus 2x squared plus x plus 5x squared plus 2x plus 5. Okay, so when you're doing this, you have to look at which terms or which things, like with those x, this would be considered a term, this would be considered a term, which of them have the same exponent. So I see that right away that 2x squared should go with 5x squared, and because you both have those x squareds. I'm going to draw a circle around them. And then I see I have an x term. So I'm going to draw a square around the x term. So we have x and we have 2x over here. And then the numbers. So we have a plus 5. I'll draw a triangle over here, and I'll draw a triangle over the 7. So this helps me keep it organized a little bit. So I'm going to rewrite all of this in order going from the largest exponent to the lowest, which would be the numbers. So we have 2x squared plus 5x squared plus x plus 2x plus 5 plus 7. And if you need to go back and check if you got everything, go ahead. Okay, so remember when you're combining like terms, you add the coefficients and then keep the variables the same. So here we have 2x squared plus 5x, 2 plus 5 is 7. So I'm going to write 7x squared. Then I have x plus 2x. Remember always that if you see an x on its own, it has an invisible 1 in front of it. In math, people don't write it because it's kind of assumed, but remember that as you're doing these operations. So we have 1 plus 2, which is going to be 3x. And then finally, we have 5 plus 7, which is 12. So that is how to combine like terms with exponents. We're going to do a little bit more of an advanced example using some negatives. So negatives are an area where a lot of people can trip up. So this is why it's good to, practice with them a little bit. So again, take a screenshot or pause the video, take your notes, and then I'm going to move on. Okay, so the next example we have is negative 3x cubed plus x minus 6x squared plus 5x cubed minus 2x squared minus x plus 5. Okay, so I'm going to do the same thing like I did with the other problem. I'm going to, draw some shapes around these to differentiate, to make sure which term goes with which term. And I'm going to be careful to include the signs in front of those terms. So with x cubes, I'll do squares for the cubes. So we have 3x cubed and we have plus 5x cubes. I'm including that plus and that minus with that. Okay, we're going to go to the x squareds now. I'll do a circle with these ones. So I'm just taking care to include the minus there. So including that minus. I'll do a triangle for the x terms. And then I'll do the 5. There's no other numbers, so it kind of stays alone. So I'm going to go ahead and write all of this in order from the terms with the largest exponents to the lowest exponent and then the number. So I'll do negative 3x cubed, my squares first, plus 5x cubed. Then I'll do the circles. So I'll have negative 6x squared minus 2x squared. And then I'll have plus x minus x, and then plus 5. So if you need to go back and check that you got all the terms, definitely go ahead and double check yourself. So here's where the negatives kind of play in. So we'll have negative 3 plus 5, which is going to be positive 2. Remember that, you think you go 3 steps back and then 5 steps forward. That means you're 2 steps forward in total. You can think of it kind of that way. Or you can also reverse it. Negative 3 plus 5 is the same as 5 minus 3, which is 2. Okay, then we have negative 6x squared minus 2x squared. So we have negative 6 plus negative 2. When you're adding negative numbers, you are going to move further negative. So negative 6 minus negative 2, which is the same, it's going to go 2 more to the back. So you can think of like not negative 6 now, but negative 8, 2 more towards the negative. So negative 8x squared. Then we have plus x and minus x. So always remember that there's that invisible 1 in front of these because there's no number written. So we have 1 minus 1, which is 0. So 0x is just 0. So I'm not even going to write anything with the x terms. And then I'm just going to bring down the plus 5. Okay, so there you have it. That is advanced combining like terms using exponents. Okay, again, pause, take a screenshot, etc. And I'm going to move on to the next topic. Okay, so the last topic is rules about exponents. So remember we had some examples. We had like, negative 5x squared plus 3x squared, right? This is something similar to what we had. When you're adding terms with exponents, you simply add the coefficients. So in this case, -5 plus 3 is -2x squared. But when you're multiplying it, it becomes different, right? Oh, not adding, but I said multiplying, right? So what you have to do is first multiply the coefficients. So we have -5 times 3, which is going to be -15. And then when you're multiplying x squared times x squared, what you're going to do is you're going to add the exponents when you multiply these terms. So we'll have x to the 2 plus 2, or -15 to the x to the 4th power, okay? So if you're having trouble visualizing this, remember that this x squared just means x times x, and this x squared just means x times x. So if you multiplied, x times x times x times x, you're gonna get, 4 x's multiplied by each other, and that's gonna be x to the 4th power. Okay, so just like another quick example, we can do like x squared times x to the 5th power, and you're gonna get x to the 7th power, right? 2 plus 5 is 7. So remember, when you're multiplying terms with exponents, add the exponents, okay? That is if it's the same variable. Don't be mixing your x and y's. Okay, so I'm gonna go erase this, pause if you need to, take a screenshot. Oh, I should just do clear screen. There we go. So the next thing we're going to work on is dividing. So say if you had 4x to the 5th divided by maybe 2x to the 3rd. Well, the way to do this would be to first divide the coefficients. So 4 divided by 2, that's going to be 2. Then x, when you divide terms with exponents, you have to subtract the exponents. It's the opposite, right? When you're multiplying, you add the exponents. When you're dividing, you subtract them, like opposites. So we're going to do x 5 minus 3, which is the same as 2x squared. Okay. So again, if you need any help visualizing this, imagine you have like 5 x's on the top, divided by 3 x's, and then these cancel out, because x divided by x is just 1. So you're left with 2 x's on the top, which is 2x squared. All right, what if we flipped it a little bit? This is where things are going to get a little bit more challenging. So we're going to do 2x cubed, and then divided by 4x to the 5th. In this case, thing on the bottom is bigger than the top. The denominator is bigger than the numerator. So 2 divided by 4, well, we have to leave that as a fraction, right? So, but we can simplify that to 1/2. And then we have x minus x3, x to the 3rd power, and x to the 5th power. Well, we know that we can subtract the exponents. So we'll have x to the 3rd power minus x to the 5th power, right? Like that. And then we'll get 1/2 x to the -2. You might be asking, I'm not sure what this negative exponent means. Well, this just means that exponent is going to be x squared in the denominator. That's what a negative exponent is. So I'm going to rewrite this as 1 over 2x squared, and that is my answer. All right, so let's do like another quick example. We can do like, say like x to the 8th power, x to the 4th power. So, just do x 8 minus 4, x to the 4th power. All right, and then last thing we're going to do is x to the 4th power over x to the 8th power, and then just subtract that, x to the 4 minus 8, then we're left with x to the -4th power. Let me erase that little guy. And remember, x to the -4th power is just going to be the same as 1 over x to the 4th. Remember, when it's a negative exponent, put it in the denominator and remove the negative sign. Okay, that's all I have today, and I gotta go help my parents with some groceries. So I will see you around. Good luck. Do some Delta math. Call me if you need any help. Stay safe, all the things. Black Lives Matter, you know. Hang in there, everybody. Have a great rest of the day. And